Greetings, students. Let's discuss practice test 5 for third quarter. Last test of this quarter, and the year's coming quick. Anyhow, so interior angle of the polygon. Why don't I teach you another way for this question? If you find the exterior, which is you can always do by 360 divided by the number of sides, 360 divided by 20 is 18. This is 18-degree exterior. The interior will be the supplement of that. 180 minus 18. 162. 162-degree interior. The exterior angle and the interior angle are supplementary on any polygon. So the measure of the interior angle here is 162. The exterior would be 18. So there's both the answers. Because sometimes they'll ask you exterior, sometimes they'll ask interior. That's how you find both. Or you can do the 180 times 18 and then divide by 20 as well. I've did in the past. 180 times 18, 3240. That's the sum, the interior angle sum. Divide by 20, 162. All right, next item. These are supplementary for any parallelogram. The adjacent angles are supplementary, or consecutive angles, I should probably call them. 35x plus 75 is 180. 75 from 180 is 105. And then 105 divided by 35 is 3x is 3. Next item. This mid-segment will equal half of these two added together. Half of 25 plus 9. So 25 and 9 is 34. If I divide that in half, I get 17. And 3 plus 5x equals 17. 17 and 3 is plus 3 is 20. And then 20 divided by 5 is 4. X is 4. So this is 17 in the middle. 17 is halfway between 25 and 9. 17 is 9 plus 8. And 17 is also 25 minus 8. All right, so maybe that'll help you remember that one. I don't know. Mid-segment, middle. All right, next item. These are also supplementary. So I'll take 24x plus 108. 100 plus 8, 108 equals 180. They're supplementary again because they're consecutive interior angles. 108 from 180 is 72. 72 divided by 24 is 3. X is 3 here. Pythagorean theorem on the next question. We're going to subtract 14 squared and 13.7 squared because we are looking for a leg, not the hypotenuse. The hypotenuse is here, across from the 90, the longest side. So I'll take 14 squared minus 13 and 7/10 squared. I'll get 8 and 31 hundredths. So the square root of 8 and 31 hundredths will be my answer. Square root of 8 and 31 hundredths is about 2 and 8, 2 and 9/10 when it rounds. Again, this is to practice using the squared key on the calculator and the square root key, which is directly above it. The squared key is here, 14 squared. The square root key is above it, second squared. You need to practice using the calculator. So you use it for the ACT and the other tests that you got to do. Alright. Measure the indicated angle. This is a SOHCAHTOA question. This is sine because opposite hypotenuse. So the sine of the angle, we can call it X or question mark. Sine of the question mark is equal to 45 over 55. So that question mark is the arc sine or the inverse sine of 45 over 55. Second sine of 45, down in the square root key there. Second sine, 45 divided by 55. It's about 55 degrees. Alright, next one, divide the trigonometric ratio. The cosine should be adjacent hypotenuse, SOHCAHTOA, S-O-H-C-A-H-T-O-A. Ka is what we want here. Adjacent hypotenuse. SOHCAHTOA. Adjacent to A is 9, and the hypotenuse is 41, the longest. Unit triangles. If this is 45, these two are both the same, and they're both the same number without the root 2. So X and Y are both 3 here. Again, we're looking at this triangle on the board. It's got a 45 and then a 1 and a root 2. So we're looking at this triangle on the board that looks like this. It's on the board. It's been there forever. All quarter. I shouldn't say forever. It's been there all quarter. We're looking at this triangle. We're saying how much bigger is this one than this one? Well, this one is 3 times bigger. Timesing by 3. 3 times bigger because it's 3 times root 2. Instead of just root 2, it's 3 times root 2. So it's 3 times bigger than the one on the board. Alright, find the missing side. This is going to be sine, because we got opposite hypotenuse labeled here. The sine of 26 is equal to 17 over x. Switch the x in the sine 26. 17 divided by sine 26. 17 divided by sin 26. It's about 39 degrees. 38.8 length. It's a length. Sorry. It's about 38.8. 38 and 8 tenths. Alternative way to do this problem is the law of sines. The sine of, x over the sine 90 equals 17 over sine 26. That's the alternative here. Next one, label a 9 here. Why 9? Because 25 minus 16. And decide what you want to use. So I want to use the x, definitely. And the x is on the same triangle with the 9 on this small triangle. It's x is hypotenuse, 9 is the short leg. On the big triangle, the whole triangle, 25 is the hypotenuse, and x is the short leg. So that's what I want to use right there. X times x is x squared. 9 times 25. I don't actually have to multiply that if I don't want to, because I'm going to square root it in the end. So because I'm square rooting here, I can just multiply 3 by 5 to get 15. Now I can use a calculator as well. So if I want to, I can take 9 times 25, I'll get 225. And I can do square root of 225 just like I did for the Pythagorean theorem up above. For number 5 up above. Anyhow, I noticed I didn't have to multiply because 9 and 25 are both perfect squares. So I was like, why not just leave them as 9 and 25? Square root them that way. Alright, so tests are always out of 100. That means I'll put 50 points on the front. So that's 5 each on the front. On the back, I've only got 6 questions because the questions are bigger. Not longer, but bigger. So this will be 50 points as well, but there's only 6 questions. So that means they're going to be worth 8 each, and I'll give you 2 free points. So these are actually 8 each. 8 points each. So don't just skip the back. Don't just ignore the back. It's going to be 8 each. All right, so we got translations, reflections, rotations, the 3 things we did this unit. So number 11 says translate right 4 and down 6. All right, well, let's just have everything right 4. 1, 2, 3, 4. And down 6. 1, 2, 3, 4, 5, 6. I tried to make it just like the homework. Right 4. 1, 2, 3, 4. Down 6. 1, 2, 3, 4, 5, 6. There's the image J, there's the image K. Now notice they're the same length apart. Translations, rotations, and reflections do not change the size of the shape. So they should be the same length apart. It should look the same size when you finish. Right 4. 1, 2, 3, 4, 5, 6. I know it seems kind of silly, but students sometimes make these look different sizes. Sometimes they don't do what I ask you to do. If it looks like it's a different size, you probably did it wrong. I'm looking visually here if this is the correct picture. So graph this for me, please. Next one. Write the rule for the translations. So it goes from pre-image to image. The images have a little tick mark on them. This little slash or this little prime symbol. They all move the same amount. So you only have to count once. But you can count all 3 if you want. So let's count for D. D is the first letter. 1, 2 left. 1, 2, 3, 4 up. left 2, up 4. E's the same. 1, 2 left, 1, 2, 3, 4 up. F's the same. 1, 2 left, 1, 2, 3, 4 up. So we got left 2, up 4. Left 2, up 4. There's many ways to write that. You can also write that as a vector, or the vector negative 2, comma 4. Or x comma y transforms, like a transformer, into x minus 2, y plus 4. Alright, many ways to write that. Take your pick. Alright, reflection of the y-axis. The y-axis, this one. So it's folding hot dog style. Hot dog style, not hamburger style. I'm not going to give partial here if you fold it over the x, because you're going to miss it on the ACTs. You're going to miss it on all the tests that matter if you fold it the wrong way. Hot dog style, if you want to call it that, the y-axis. So Q comes over to here. Y, because it's 2 left, it's 2 right. R, again, this is going to be the same distance apart. So is it here, is it here? Well, it's here. Because look, the same length. There's R. And S, well, that's going to be, is it here or is it here? It's here. Because again, it's the same length apart. Or you can count 1, 2, 3 left, 1, 2, 3 right. R is 4 left, 4 right. Again, the shape looks the same size. If it looks like it's a different size, you did it wrong. Now, what did I do here? Reflected hamburger style. From top to bottom, reflected on the x-axis. So I reflected along this line, the x-axis. You say cross or on the x-axis, either one is actually appropriate. I don't remember the language I used in the notes. You kept reflecting across or on the x-axis. They're both appropriate language there. Alright, 15, rotation 90 counterclockwise. So if we're going to rotate 90 counterclockwise, which way am I going? I'm going to turn the paper to the right. I'm going to turn the paper to the left. So which way is counterclockwise? That's the question here. So 90 counterclockwise is left. 90 clockwise would be right. So keep it straight. So here's my original points. I'm going to rotate it 1 quarter turn to my left. I'm going to figure out where the new points are. J is now at 5, negative 1. So let's plot J. 5, negative 1. There's its image. K is now at 3, 3. Let's plot K. 3, 3. There's the image of K. L is now at 5, 3. Let's plot L. 5, 3. Again, the shape did not change sizes. It rotated like a windmill or like the blades of a fan. So it was here and it rotated here. The blades of a fan, just like the blades of a fan. Alright, next one. Write the rule of the translation. What happened here? Did I move 90 counterclockwise, 90 clockwise, or 180? So I'm looking at this and I'm saying, here's the original. If I spin a quarter turn left, I end up in quadrant 3. So I went a quarter turn to the left. Is what I did here. So is that 90 clockwise or 90 counterclockwise? And I go left. That is counterclockwise. If I had gone right, and I ended up in quadrant 1, so if this was in quadrant 1, started off in quadrant 2, if it was in quadrant 1, to the right, that would be clockwise rotation. This is 90 counterclockwise. 90 degrees counterclockwise rotation. And again, rotation has a center of rotation. It's about the origin. About the origin. Remember, these are 8 each on the back. So if you want to get your maximum points for question numbers, study the 8 on the back, or 6 on the back. Because they're 8 each, they're 48 points, 50 points total for the back. Just giving you 2 for free. Good luck!